Hello everyone, this is Mr. Appel, and today we're going to learn how to construct a triangle that is congruent to a given triangle. This is an idea we're going to come back to later in the year and look at multiple different ways of doing this construction, but for now what we're going to do is just use our very first construction, which is just copying a segment. We know how to copy one segment, so there's no reason we can't copy all three segments, in other words, the three sides of this triangle, and that's basically what we're going to do in this construction. So to start, I'm going to start with, and I'm going to keep it oriented the same way, it's a little easier to follow. We'll look at a little later at what happens if the orientation is different. It doesn't make a difference, but sometimes it can be a little tricky. Okay, so I'm going to start with just a segment that's longer than I need to start with, and I'm going to use this endpoint here and just call that J, just as a reference. So I need to find where K and M are. So let's first start with K, because that's easy, right? I can copy segment JK. Haha, JK, it's a joke. Okay, it's not a joke. This is a very serious construction, so no joking allowed. All right, enough with the really bad humor. So I'm going to go ahead and open this up to the length of JK. We're just going to copy that. This should be a pretty straightforward step. Pretty easy construction. And I'm just going to mark that little intersection there, and I'm going to label this point K. And you know that this JK is congruent to this JK because I used the same width. Okay, now I need to find point M. So here's the thing. I know that point M is JM away from J, but it's also KM away from K. So if this, I'm making up numbers here, if this was like 5 inches and this was like 3 inches, I'd need to find a point that's both 5 inches away from J and 3 inches away from K. So we're not using actual measurements, but we are using our compass. So let's start with finding all the points that are JM away from, JM away from J. So I'm going to open the compass up to the length of JM, and I'm going to take that center, put it over here on J, whoops, make sure it's on J, and I'm going to make an arc out here somewhere where I expect the intersection to be. So all of these points on that arc are that distance JM away from J. So now I need to find the point that is also KM away from K, and where they intersect will be my hotspot. Whoops, really this is much easier to do. I'm going to do this upside down because I'm running out of space there. There we go. So I'm going to open that up, open that up to the length of KM. I'm going to put my center, which is on K, I'm going to put it on my new K, and I'm going to see where they intersect. And again, when I make that arc, all I need to see is where they intersect. And now this point is KM away from K, and it's also JM away from J, so that must be the point where M could be. And if we go ahead and draw segment JM, and then also go ahead and draw segment KM, we've got our triangle, and there it is. And it did a pretty good job. It's not perfect. I can take this and put it over and see. Yeah, it's pretty good. It's a pretty good copy. One little interesting note, there's actually another way you could have done this. If you had extended this arc, that first arc, it would have, continued on down here somewhere, and if you'd continued this arc, it would have continued down here somewhere, and you would have had another point where M could be. Well, you could have gotten that congruent triangle flipped over, and you would have had this, and it still would have been congruent. You would have found this point M instead of this one. So you could have actually had two perfectly fine solutions to this particular problem. Just an interesting little tidbit, and that's all for today. Thanks.